Have you ever wished you could slow time down, just a little? Like making a stressful moment feel calmer, or letting a good moment last longer? Here's the surprising part. In physics, time really can slow down. Not as a feeling, literally. It's called time dilation, and it's one of the most fascinating, well-tested ideas in science. To understand it, start with a simple thought. We often treat time like a steady stream. 1 second for me is 1 second for you, everywhere, always. But Einstein showed that time doesn't work like that. Time is connected to motion and gravity, and it can stretch. Imagine two identical clocks. One stays on Earth. The other goes on a very fast trip through space and comes back. According to relativity, the traveling clock will tick a tiny bit slower. When it returns, it will show less time has passed compared to the clock that stayed behind. So the traveler has, in a sense, moved into the future relative to Earth. Why? Because light has a maximum speed. And as something moves faster, it doesn't only change its motion through space, it also changes how it moves through time. The faster you travel, the more time slows down for you compared to someone who isn't moving as fast. That's motion-based time dilation. But gravity does something similar. Picture space-time like a stretched fabric. A planet creates a dip. The stronger the gravity, the deeper the dip. And clocks near stronger gravity tick more slowly. That means time moves a little slower at sea level than on a mountain, slower closer to Earth than far out in space, and much, much slower near a black hole. Near the edge of a black hole, gravity becomes so intense that time dilation can become dramatic. From far away, you'd see an object appear to slow down as it approaches the event horizon. But for the object itself, time feels normal. It keeps moving forward. That difference in perspective is the heart of relativity. Time depends on where you are and how you're moving. This sounds like science fiction, but we've tested it in the real world. Using extremely precise atomic clocks, scientists have compared clocks on airplanes with clocks on the ground. The clocks ticked differently, exactly as relativity predicted. Even GPS satellites have to correct for time dilation. Their clocks run at different rates because they're moving fast and they're in weaker gravity than we are. Without those corrections, GPS would slowly drift and become inaccurate. So time dilation isn't just an idea. It's part of modern technology. And here's the bigger takeaway. Time is not one universal beat. It depends on your path through the universe. Once you see that, you start to view reality differently. The universe stops feeling simple and starts feeling far more interesting. If you want, the next step is to ask, could time dilation ever let us travel far into the future? And what would that actually take?